Lesson 46, Rational Exponents. Now the word rational in a math class basically means fraction. So notice we've got exponents, which are fractions. That's what we're playing with today. So what do you do with these things? Well, the definition of a fraction exponent, or maybe I should say the interpretation, if you've got x to the 2/3 power, like that. Okay, the 2 is an exponent in the usual way. So this is like an x squared, but with a little something extra. That little something extra is a cube root. The fraction indicates a root. So this means the cube root of x squared. Okay, it's not x squared, it's x squared in a cube root. So again, it's like a two-part exponent. It's a two-part exponent. That's a normal power. The 2 is, the numerator is, and that would indicate the root. It's the index of a root. The 3 is a cube root, a 4 is a fourth root, and so on. That's what it is right there. So you got to keep the numbers straight, right? The denominator is the root. Now this 8 to the 2/3, you could write it the same way, but usually when I'm playing with numbers, I actually write it slightly different. I'll write the cube root of 8, and then I'll square it. So notice it doesn't matter whether you put the square on and then put the cube root on, or whether you first put the cube root on and then put the square on. It actually does not matter. And when I say it does not matter, I mean that I really could have just done it this way. Cube root of 8 squared. It would have worked out exactly the same. Now when I'm playing with variables, this is the point I'm trying to make. When I'm playing with variables, I usually leave the exponent inside. It just looks neater, I think. And when I'm playing with numbers, I often put the cube root and then I'll square outside. And why would I want to do it that way? Because look, the cube root of 8, in fact, maybe I'll get a different color for this. The cube root of 8 is just a 2. And so I've got a 2 squared, and that's easy for me to figure out. It's a 4. Yay. Now just to show that it works the same way this way, I could say 8 squared is 64, but notice I'm getting bigger numbers, and if I had a 12 squared, it would be even bigger or whatever. But it still works because 8 squared is 64, but the cube root of 64 really is 4. 4 times 4 is 16 times 4 is 64. So again, order does not matter. Order no matters. I think that's correct enough English, right? Order no matters. It doesn't matter whether you do the root first or the power first, but the top is a power, the bottom is a root. Okay, that's the main thing. Now it takes a little getting used to, and that's why I've got a lot of examples on page 1. What do I got? 5 examples? I got 5 examples on page 1 where all we're going to do is evaluate fraction exponents, numbers that have fraction exponents on them. So this one, see if you can figure that out just by looking at it. Okay. I would do this way. I would say, I wonder if I can take the 4th root of 16. If I can, I will, and then I'll have to cube it. Okay, so there's the power of 3 right there, and then there's the root of 4 right there. Now the 4th root of 16, it turns out, does come out even. It comes out to a 2. 2 times 2 times 2 times 2 is 16, and so I've got 2 cubed, which means I've got 8. Notice it's nothing like taking 3/4 of 16 and getting 12. It's nothing like that at all. It's 4th root of 16 and then cube that. You end up with an 8. What do you think of this one? Example 2. 4 to the minus 1/2. Oh, this is a 3-part exponent. Actually, this is the power of 1. That's not a hard thing to do. Raise something to the 1 power, right? Now an index of 2 is going to mean a square root. But it's also negative. So you got 3 things to do here. And the good news is it does not matter which one you do first. You can do it in any order. In fact, I invite you to try it in different orders. I'm just going to do it in one order. I don't even know what order yet. I know what I'll do. First, I'll flip it, just because. Negatives bug me. So there I go. I flipped it. It's 1 over 4 to the 1/2. But 1 over 4 to the 1/2. Well, 4 to the 1/2 is 2. It's the square root of 4, which is 2. So this thing ends up being just a 1/2. It's just a 1/2. Cool. What about this one? Same ideas, except this time I've got, well, not all the same ideas, I guess. This is a square root. A 2 denominator indicates a square root. This is a power of 3. Now the exponent's not negative, the number's negative. Now remember the exponent is not on the negative 4, it's just on the 4. So I have a negative out front. This part goes here. Now, that says square root of 4 is being cubed, right? Just make sure you've got them both in there. I have to have a square root somewhere. I do. I have to have a power of 3 somewhere. I do. There it is. It works. You could, if you wanted, do it in the other direction. You could cube the 4 and then take the square root. But I'm just doing it this way. And so what do I got? I got a negative, and the square root of 4 is 2. And so when I cube that, I'm ending up with a negative 8. What about this one? I got a 4/9. I got to do a couple things here. I got to flip it over. Maybe I'll do that right now. I'll just flip that over. Remember, a negative on an exponent is telling you to flip it, to take a reciprocal. You could say move it over the fraction bar, but in this case, both the 9 and the 4 are moving over the fraction bar. I got 9/4. To the positive 1/2. Now, a power of 1 doesn't do anything. The 2 is a square root, so basically I've got a square root of 9/4, which is the same thing as the square root of 9 over the square root of 4. So what we're ending up with is a 3 on top and a 2 on the bottom. That's just a 3/2. All right. You want to try this one? Good idea to try that one before you look at my solution. Okay, ready? First of all, this negative in front has nothing at all to do with that exponent. Nothing. Nothing. So in fact, maybe what I'll do is I'll highlight that and I'll say it equals negative. And that negative is just coming along for the ride. Now, meanwhile, I'm going to have to do a 3-part exponent here on the negative 8 over 27. So if I maybe flip it first, just because I can, I don't have to, but I can, I'm going to flip it first. Now my exponent is positive. Okay, from here, I got a couple choices. Do I feel like taking the negative 27/8 and squaring it? Ooh, heavens, no, I hope I don't have to do that. I could instead cube root it first and then square. Yeah, I think I'll do it that way. I will cube root it first and then square. So what have I got here? I've still got this negative out front. This negative has just been there, and it's just going to stay there. But inside here, I am going to, first of all, the cube root of a negative is a negative, right? The cube root of a negative is negative, so I can just leave that negative there. The cube root of 27 is 3, and the cube root of 8 is 2. So I've applied my cube root to both the top and the bottom, and actually to the negative. Cube root of a negative is negative. Now what? Okay, now still, this negative here, this one in front, it's just going along for the ride here, right? This exponent of 2 is on the negative 3/2, and exponents come before multiplication, where you may be thinking a minus times a minus is a plus. Don't you dare, because the exponent has priority. Man, they should really move the eraser somewhere else. Anyway, the exponent has priority. So that negative stays there. Now I have to take that negative 3/2 and square it. Now, when you square a negative, it goes positive. And so 3 squared is a 9, 2 squared is a 4. And so in the end, what have I got? A negative times a positive is a negative. This thing all comes out to a negative 9/4. Whoa. So this big mess is the same as this little not so mess. Okay, but you have to be able to, of course, apply all these various steps. So there's kind of a lot of steps involved, but that's okay. You just need to know how to take a cube root, how to square, how to flip something over, and be very careful about your negatives. And is the exponent on this negative? Is it on that negative? What's the exponent on? Exactly. Okay. So that's the basic idea. That's how you play with your fraction exponents. Again, top is a power, bottom is a root. Now, for these next ones, we're not going to do so much of that. We're just going to use the laws of exponents like we usually do. You know, sometimes you have to, like if you had x to the 5th squared, you would multiply your exponents. If you had x to the 5th times x to the 4th, you would add your exponents. I really hope I said multiply up here, right? Multiply 5 times 2 is 10. Here I'm adding 5 plus 4 is 9. That's what I mean. And then the old, you can subtract exponents if you have something on the top, something on the bottom. That's what I mean by the laws of exponents. It's in this case, though, we just, Quite frankly, we get to practice with our fraction arithmetic a little bit more. But let's do that. So here, this first term, it looks like what I should be doing is I should be multiplying these two exponents together. What do you get when you multiply a negative 2/3 times a negative 1/2? I'll show you what you get. First of all, you get a positive. Now, when you multiply fractions, that is the one time in the world that you're allowed to cross cancel. So I'll cancel those 2's off. So what am I left with? Well, that leaves a 1 behind. So on the top, 1 times 1 is 1. On the bottom, 3 times 1 is 3. That's a 1/3. Okay, now let's multiply the negative 4 times the 3/4. Well, I can make the negative 4 look like this, negative 4 over 1. And I will, because for one thing, it's easier to see that I'm canceling 4's here. So what does this come out to be? Well, it's a negative times a positive is a negative. Notice it's 1 times 3 is 3 on the top, and it's 1 on the bottom, but you don't really have to say over 1, right? So it's just a negative 3. Maybe I should write that a little bit better, like this. Cool. So back to our problem. We had x to the power of, and we multiplied those exponents, and we got a 1/3. And then we had, over here, we had x to the power of, and we multiplied those exponents and got a negative 3. So here's what we're looking at now, after multiplying exponents. Now what? Now we have to add those exponents, right? So I have to add a 1/3 and a negative 3, which is the same as 1/3 minus 3. So to do this, you have to do your old common denominator thing. So looking at a 3 and a 1, my denominator is going to have to be 3, so I do the old times 3 top and bottom trick. So what I got is a 1/3 minus a 9/3, which is a negative 8/3. So where are we? When you multiply these two things together, you have to add the exponents, and that will get you, come over here, x to the negative 8/3. Almost done. We don't want a negative exponent, so just flip it over. 1 over x to the positive 8/3. Remember, the negative just says, I'm unhappy. I'd rather move over the fraction bar. What fraction bar? That fraction bar. I'd rather move over the fraction bar downstairs. Take the reciprocal, i.e. move it down. 1 over x to the 8/3. That's a much nicer looking thing than that, right? So it's good to be able to reduce your, or simplify your expressions involving these negative exponents. So I didn't even have to bring in the old, denominator means cube root. I didn't even have to do that because it didn't say put it in radical form or anything. It just said simplify using laws of exponents. Well, I did. This one, simplify using exponents. We don't even need that whole radical stuff anymore, or for this anyway. So, my tip with this thing is when you have negatives inside like this, think of this as like a negative 1 multiplying the x, and then apply this exponent separately to the negative 1 and to the x. So by saying that first, I invite you to pause and give this a twirl. I'll assume you've unpaused. Okay, so this first thing here, I'm going to call that a negative 1 with an exponent of negative 4/3. And the x is going to be to the what? I have to multiply these two exponents together. Negative times negative is plus. 1/3 times 4/3 is 4/9. Cool. Now, looking at this thing, I've got x to the, and if you multiply a 3 times a negative 2/3, notice the 3's are canceling, and you just get a negative 2. Get that out of there. That's on top. Now on the bottom, what have I got? I've got a negative 2 that does not have an exponent on it. Notice it does not have an exponent on it. And it's multiplying x to the negative 2. Okay, cool. Now this is actually something that's kind of nice. See how that's an x to the minus 2 and that's an x to the minus 2? Are they not the same? Do they not cancel? Yeah, they cancel. They just cancel. It's identical, it cancels. Bada boom, bada bing. So what have I got here? I've got, well, let's see now here. Let's think about this for a second. If you take a negative 1 and you apply this exponent to it, what do you get? Negative 1 to the negative 4/3 is what? Well, if you flip it over, If you take negative 1 and flip it over, you get 1 over negative 1, which, guess what, is negative 1. So the negative part of that exponent actually means nothing in this case. The 3 means I should be taking the cube root of 1, and the 4 means raise it to the 4th power. Well, the cube root of 1 is 1. The 4th, and you raise that to the 4th power, is still 1. That's just 1. That's just equal to positive 1. That's kind of cool. So the negative 1, since it's raised to a cube root, it's going to go negative. It's going to stay negative. But since it's also raised to an even power, that makes it positive. And flipping over a 1 doesn't change it. It's still a 1. So it's just a positive 1. Well, that was easy. Or not easy, but it ended up with an easy result, is what I should say. So what have we got here? We've got an x to the 4/9 up here, and on the bottom we've got a negative 2. And the last thing to do is, remember, if you have a positive divided by a negative, it comes out negative, so just write it that way. Put the negative in front. Please don't leave your negative in the denominator. It looks terrible. So there we are. We've done it. Yay. All right. What else we got? Oh, now we're going to go back to our, remember that the root means, the denominator of a fraction exponent means root. So like this one, it says rewrite using a rational exponent, which means, again, a fraction exponent. Use a fraction exponent. Okay, well, the 3 only has an exponent of 1. Who cares? But the x is inside of a square root, which means index 2 root. You would just write 3x to the 1/2. So you've converted that to something with a fraction exponent. Cool. By the way, this means that if you ever do something like this on your calculator, hey, I want the square root of 17, you could, if you want, use the square root button, or you could, if you want, use the exponent button. And what I'm trying to say there is raise it to the 1/2 power. Come on, you. Come on, you. Raise it to the 1/2 power, which on a calculator is 0.5. You could raise 17 to the 0.5 power. You will get the same thing as if you had used the square root button. So this is a sort of a direct application of rational exponents. Square root means 0.5 power. It really does. That's all it means. Try that on your calculator. You'll see. You'll say, wow, the decimal came out exactly the same. Cool. So again, a square root means a fraction of 1/2 exponent. So here, both the 3 and the x are in there. So it's kind of like both the 3 and the x have a 1/2 exponent. I'm actually pretty happy with that. Or you could split it up like this, 3 to the 1/2, x to the 1/2. Actually, I might even be happier with that. I'm even happier with that because there's no parentheses. It looks cool. It looks cool. 3 to the 1/2, x to the 1/2. So the main thing is here, notice the difference between, well, actually look at this. If you have 3x to the 1/2, it's 3 and only the x is in a square root. Whereas here, they're both inside the square root because they both have an exponent of 1/2. Okay, what do we got here? Well, this one's kind of funky. I'll show you the shortcut first, maybe. The shortcut is to say x is to the 8th power, but it's in a 4th root. So that's 8/4. Y is to the 2 power, but it's in a 4th root. Y to the 2/4. That's the shortcut. The long cut, if you like taking the scenic route, I suppose you would go something like this. You take the x to the 8th, y squared. Being in a 4th root means it's to the 1/4 power. Then you would multiply these exponents. But what do you get when you multiply 8 by 1/4? You get 8/4. What do you get when you multiply 2 times 1/4? You get 2/4. Okay, so I just did the shortcut. You don't mind that much, do you? So, of course, we can reduce these fractions. So x to the 8/4 really is the same as x squared. 8/4 reduces to 2. 2/4 reduces to 1/2. So, yeah, reduce your fractions. So that's that. Okay, this one's one of my favorites. Hint, 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 hint. This one's one of my favorites. So what do we got here? Well, on the top, they're both in square roots. So x is in a square root, and so is y. So you can write that as x to the 1/2, y to the 1/2, right? Just like up here, when we had both the 3 and the x in there, we ended up with 3 to the 1/2 and x to the 1/2. It's the same idea. They're both in there, they both get 1/2. Underneath, these both get 1/3 because they're under a cube root. So this is going to be x to the 1/3, and this is going to be y to the, actually it's squared and then in a cube root, so it's y to the 2/3. So there, we remove the radicals. Of course, we should simplify this mess. So remember, you can subtract exponents on the x here, so we should. Remember how to subtract fractions? You have to do the old common denominator trick. So times 3/3 makes that a 3/6. Times 3/3 makes that a 2/6. So x is to the 1/6. Same thing on the y's. It's the top one minus the bottom one. So 1/2 minus 2/3. So that would be a 3/6 minus a 4/6. So that's a negative 1/6. So what do we get then? On x, we have an exponent of 1/6, and on y, we have an exponent of negative 1/6. That looks a lot simpler already. One more step. It'd be nice to have a positive exponent. Oops, that's not how you do it. It'd be nice to have a positive exponent, so this, having a negative exponent, remember it's sad, it wants to move. It wants to move to the other side of the fraction bar, which means it wants to basically come downstairs to here. So it's x to the 1/6 on top, y to the 1/6 on the bottom. So yeah, sometimes these fraction exponents give you a really nice, sort of a cheater's way to simplify these kinds of things, especially if you have different kinds of roots, square roots, cube roots, fourth roots, whatever. If you got different kinds of roots all mixed up, you may just want to go to fraction exponents. And then the last kind of thing we're going to do is go in the opposite direction. Here I have the fraction exponent. What I want is the radicals. So this is related to what we were doing on the first page, right? Except on the first page we had the numbers, so we were just like taking cube roots of numbers and then squaring the numbers and so on. Here we got x's going on, so it's a little more involved. So let's see now here. X to the 1/2, we got to play with this 1/2 here. Notice it's on the x, it's not on the 3. So this is 3, and this means a square root, and actually we're done. That's all there is to that one. It's 3 times the square root of x. Bada boom, bada bing. Just remember again, the 3 is not in the square root, just the x, right? The exponent is only on the x. What do we got here? X to the minus 1/2. So that's going to be a square root of x, all right, except flipped over, which reminds me of Despicable Me. Flipped over. Anyway, 1 over the square root of x. That's what it is, right? It's a 3-part exponent. I need x in the square root. I also need the thing to move over the fraction bar, move downstairs. So it's 1 over the square root of x. Now the thing is, remember, simplified radical form means you're not going to leave a square root in the denominator. You're going to pull this old stunt. The old square root of x times its square root of x is just regular x. This is a happy denominator right there. Happy, happy. We don't want square roots in our denominator. What do we got up top? Just 1 times the square root of x. So that's all that is. That would be simplified radical form. Here you put it into radical form, I suppose. But simplified radical form, remember there's the 6 criteria. You have to like reduce. Well, there's 6 ways to reduce. This is one of the things you have to do. You have to make sure your denominator does not have a radical in it. It's called rationalizing the denominator. Okay, this one's slightly more involved. What do we got here? Cube roots. We got x and y, but we have cube roots. So I'm taking a cube root of x, x to the 1 power, that's nice, but the cube root of x, and it has to move downstairs. So I'm just going to move it downstairs like this. Okay, fine. Now what about this y thing? This y is also in a cube root. It's a positive exponent, so it stays up here. But it's y to the 4/3, which means it's y to the 4th inside of a cube root. So that's directly interpreting our exponents, so to speak. Now comes the part where we put it in a happy, simplified radical form. Up here, that's a no good. You got a cube root. You shouldn't have any exponents in it that are 3 or any bigger than 3. That needs to be reduced. So remember, y to the 4th is kind of like having a y cubed times another y, right? And why am I doing this? I'm doing this because I know I can simplify that part. The cube root of y cubed is just y. And so what I got here really is I have a y on top and then times a cube root of y. Okay, so that's what's on top. Maybe I'll come underneath here and sort of start over. So the top has simplified to this, y times the cube root of y. The bottom is still this cube root of x, which I really don't like because we don't like radicals in our denominators. So we have to fix it, and the way you fix it is almost the same way as what we were doing up here. Not quite. We do want to multiply top and bottom by cube root of something, but you got to remember how this goes. I'm trying to make, in order to apply a cube root and have it go away, I need to have a cube here. Or more accurately, I need a power that's either a 3, 6, 9, 12, or so on. In this case, I need a power of 3 on that x. Well, right now, it only has a power of 1. I'm going to have to multiply by a power of 2 in order to make that an x cubed, right? So this times this is x cubed. That's what I want. So I'm going to have to multiply by x squared, top and bottom. So the good news is that the bottom simplifies quite nicely. So when you multiply cube root of x times cube root of x squared, you get cube root of x cubed, which is just x. So we got rid of the radical in our denominator. Up top, just kind of put this stuff together. Outside is a y, and then I can combine all my insides. I'm multiplying cube root of y, cube root of x squared. That's going to give me, quite literally, cube root of x squared y. And there's that one. I believe this is the last example, isn't it? Yes, it is. The last example. Maybe you'd want to pause and try this yourself. Maybe not, but in any case, here we go. Once more, remember the exponent is on x. The exponent is not on the negative 4. The exponent and the negative 4 have nothing to do with each other. So this is going to be a negative 4. That's what it's going to be. And this is going, since it's a negative exponent, this x thing is actually going to move down to the bottom. And it's going to be a cube root. And inside is going to be an x squared. This is how we begin this one. The negative 4 stays there. It doesn't have an exponent on it. Well, I guess it has an exponent of 1, really. But the negative 2/3 has nothing to do with the 4. Leave the negative 4 there. Cube root of x squared on the bottom, because it was a negative exponent, on the bottom. Now, this one, boy, this one's a little easier than the other one. We still have to fix the denominator, so we're going to have to do the old multiply top bottom by the cube root of something. Now remember, the whole point is to build a cube inside. Build a cube inside. Exclamation point. That's what we're trying to do here. So x squared times what? Well, it'd have to be x squared times 1, x to the 1. That gives me x cubed. So I'm multiplying top and bottom, basically just by the cube root of x. So the top is negative 4, multiplying cube root of x. That is what it is. The bottom, if you multiply the x squared times the x, you get an x cubed. And again, why are we doing this? Because this simplifies. This simplifies to just. I get a negative 4 cube root of x on top, and on the bottom I've got just an x. This is a nice way to write your answer. Now, if you prefer, you could put the negative in front. This is also a nice way to write your answer. I don't mind negatives that are in the numerator up here. That doesn't bother me at all. Just, you may have seen me complain, though, if you ever have like a if you ever have like a negative in a denominator, that's ugly. Just call that a negative 1/2. That's what that is, right? Positive divided by negative is negative. Just call it negative 1/2. Never leave a negative in a denominator. It's hideous. Negative in the numerator? Why not? Out front is probably a little better, but I'm not going to deduct points over it. Let's not quibble over that. Okay, so anyway, it looks like we did I think we got it all. Boy, that went faster than I thought it would. So fraction exponents. It's all about the denominator means root. That's the main point. Okay.